In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet multiplying a polynomial and a monomial. And our directions for this worksheet are to find each product. Remember, a polynomial has multiple terms in it, and a monomial just has one single term. So looking at number 1, you can see here is our monomial, and this is our polynomial because it has multiple terms. So what we're going to do is figure out how to multiply those together. And how we do so is we're going to take the monomial and multiply it into each term. So the 8x will get multiplied by the 6x, and it will also get multiplied by just the 6 with addition in between. Because this is like the distributive property. We have to take this and distribute it into both terms. And that's due to the fact that we have this order of operations, or PEMDAS, that we go by. Parentheses is first. But because we cannot evaluate the parentheses, because there's some variable, and we can't add this term with a variable to a term without, especially since we don't know what that value of the variable is, then in order to find the product, we're going to have to distribute through in order to get rid of those parentheses. So let's go through breaking down each step. So 8x, like we said, that monomial is going to get multiplied to the first term 6x, but then it's also going to get multiplied to the term 6 with addition in between. So we're going to have 8x times 6x plus 8x times 6. 8x times 6x plus 8x times 6. Now what we're going to do is do this multiplication out. Because multiplication is commutative, 8x times 6x is like 8 times x times 6 times x. So how I'm going to simplify this down, I'm going to do 8 times 6, which is going to give me 48. And then I'm going to multiply x by x. X plus x would be 2x, but x times x is x squared. So that's our first term. Now there's addition, and we're going to do out this next multiplication. 8x times 6, which 8x is the same as 8 times x. So I'm going to do 8 times 6, which is 48, and then that gets multiplied by x. So we have 48x squared plus 48x as our solution for number 1. So let's continue on to number 2, talking through this again. In number 2, we have our monomial, our single term of 7n, and that's multiplied to 6n plus 3. So because it's multiplied to that polynomial, where there's terms in those parentheses, we're going to have to distribute the 7n. So we're going to do 7n times 6n plus 7n times 3. So writing that out, we'll have 7n times 6n plus 7n times 3. Now remember, multiplication is commutative, so I can multiply the 7 to the 6 before I worry about multiplying n. So 7 times 6 is 42, but what's left? After I multiply my 7 and my 6, I still have an n that's multiplied by an n, and that's where I'll get 42 times n squared, or 42n squared. And then I'm going to add that to 7 times n times 3. I'm going to do the 7 times 3 first, which is 21. So that's 21 times n, or 21n. And that's our solution in number 2. Notice that because I had addition within that polynomial, I keep my addition after I distribute through. And in the next one, we're going to see a problem where we have subtraction in between. Let's move on to number 3. In number 3, we have 3r, our monomial, multiplied by 7r minus 8, our polynomial. So we're going to take our monomial and distribute it into each term in our polynomial. So 3r will get multiplied to 7r, and 3r will also get multiplied by 8. But look, in between is subtraction. So we're going to have to remember that. So we'll do 3r times 7r, and we're subtracting, because there was subtraction in between, that's going to be our 3r times 8. Now, it's similar to the way we did it above with addition. Because multiplication is commutative, meaning we can multiply in whatever order we want, as long as all the terms are multiplied together, we're going to go ahead and do the 3 and 7 first. So 3 times 7 is 21, and then we still have r times r, which is going to give us r squared, and we're subtracting 3r times 8, which it will be easier to multiply the 3 and 8 together since that's possible. So we'll do 3 times 8, which will be 24, and that gets multiplied by r. So our solution for number 3 is 21r squared minus 24r. And again, that's because there was subtraction in between those terms. When we multiplied that monomial, that subtraction remained. Let's move on to number 4. For number 4, we also have subtraction. The difference here is that our monomial is just a constant. So we're going to multiply 8 into 8k and then multiply it by 8 with subtraction in between. So we're going to have 8 times 8k minus 8 times 8. Order of operations, we start with multiplication first. So we're going to figure out this term, and then we're going to figure out this term, because those are the ones that are multiplied together, and then we're going to leave that subtraction in between. So 8 times 8k is going to be 8 times 8, which is 64, times k, minus 8 times 8 is 64. So we have 64k minus 64. That's our solution in number 4. Let's move on to number 5. In number 5, we have 10a, and that's going to get multiplied to a minus 10b. So what we're going to do is distribute this 10a through. It will get multiplied to a, and it will get multiplied to 10b with subtraction in between. But I want to note here that we have more than one variable. We have a, but we also have b now. So let's see how that's going to affect our problem. Well, 10a times a, those will get multiplied together, and then we subtract 10a times 10b. Again, that was just distributing this monomial to each term in our polynomial. So let's simplify these down. So 10 times a, because that's all multiplied together, is the same as 10a squared. Because the a times a is an a squared, so 10 times a squared. And then we're going to subtract. Now here's where it becomes a little different. We can combine 10 times 10 because those are both numbers, so that's going to give us 100. But a times b, we don't know what those values are, so it's just going to stay as a times b. So we're going to have 100 a times b, or 100 ab, as that term that's subtracted. So our solution is 10a squared minus 100ab. And again, we can't combine those variables together because we don't know what those values are. However, we can indeed combine variables that are the same, but we cannot combine variables that are different. Let's move on to number 6. In number 6, we have two different variables again, so let's see how this problem is going to play out. Well, our monomial is just that single value of 2, and that's going to get distributed into 9x and distributed into 2y with subtraction in between. So writing out 2 times 9x minus 2 times 2y. Notice that the variables are not even in the same terms, those different variables, so we're not going to have to worry about multiplying them together anyway. It's just going to be 2 times 9 times x, which is going to be an 18x, minus 2 times y, which is going to be a 4y. And there we have it. That's 2 times 9x minus 2y, that monomial multiplied to the polynomial, the product of that multiplication. Let's move on to number 7. For number 7, we have 7x times 6x plus 4y. Now note, if this 4y was actually a 4x, I just want to point out that we wouldn't need to even distribute through right away. If this was a 6x plus a 4x, we would be able to add those together because they're like terms. And what I mean by that is they both have the same exact variable to the same exact degree. Both are x to the first. A 6x plus a 4x, 6 of some variable plus 4 of that same exact variable is going to be 10 of that variable. So it would just be 10x. And then we can multiply by that 7x. But unfortunately, that's not the case. This variable is y, and we have no way to combine x to y since we don't know its actual value. So we need to distribute through. So we're going to take our monomial of 7x and distribute it into each term with addition in between in this case. So we're going to have at the start 7x times 6x, and that's going to get added to 7x times 4y. Now when combining these, doing the multiplication out, 7 times x times 6 times x, that is 42 times x squared. Because 7 times 6 is 42, x times x is x squared, and I can't combine that 42 and x any further. So 42x squared. And then I'm going to add that to 7 times x times 4 times y. 7 times 4 we can easily multiply. That's going to give us a 28. But x times y we cannot combine, so we're going to leave it as x times y. So xy. And there we have it. 42x squared plus 28xy. That's our solution for number 7. Let's move on to number 8. Again, similar to number 7, because this is an 8a and an 8b, a is not the same variable as b, so we cannot combine what's inside of parentheses, so we definitely need to distribute through. So we're going to take 4a, multiply it to 8a, and then with subtraction in between that, we're going to then multiply it to 8b. So let's go ahead and write this out. 4a times 8a minus 4a times 8b. We can multiply 4 times 8, that's going to give us 32, and we can multiply a and a together because they're the same variable. That's going to be a squared. Now we have to subtract the multiplication of 4a and 8b. 4 times 8, again, is 32, but a times b cannot be combined, so we're just going to leave it as ab. So 32a squared minus 32ab is our solution for number 8. Let's move on to number 9. In number 9, we're going to have 3n times the polynomial n squared minus 6n plus 5. How this problem is different from the other ones is here is our monomial still out in front, but look, we have 1, 2, 3 terms inside our polynomial as opposed to all the previous problems, there were only 2 terms. But that's okay. We still distribute the monomial through to every single term. So we're going to take 3n and multiply it by n squared. Then we're going to take 3n and multiply it by 6n. And we're going to take 3n and multiply it by 5. Now let's remember the signs though, because we're going to do 3n times n squared, but then we have to subtract 3n times 6n, and then we're going to add 3n times 5. So writing that out, we'll have 3n times n squared, and then we're subtracting, so minus 3n times 6n, and then we're adding 3n times 5. So just make sure to keep track of whether it's addition or subtraction in between those different terms. So starting with the first, we have 3n times n squared. Well, the only thing we can combine through multiplication is n and n squared, because n times n squared is going to be an n cubed. We just have an extra n, so n squared is really n times n, so we have 3n times n times n. N times n times n is n cubed, and that gets multiplied by a 3. And again, if you want to see this, n times n squared is the same as n to the first times n, which is equal to n to the 1 plus 2, because we add those exponents together. N to the 1 plus 2 equals n cubed. Or if that confuses you, those laws of exponents, break down n squared. N squared is n times n. So we have n times n, because that is n squared. How many n's are we multiplying together? 1, 2, 3. 3 n's are getting multiplied together, so that's going to be n cubed as that solution. Just a couple different ways to think about it. This method is fairly easy when you're dealing with smaller values, but think about if you were dealing with n to the 13th and n to the 12th. Writing all those n's out might get a little tedious. That's where adding those exponents might be a little bit easier. But let's keep moving on, doing however you find it most helpful. So, now that we have our first term, we're going to subtract 3n times 6n. 3 times 6 is 18, and n times n is n squared. So 18n squared, and then we're going to be adding 3n times 5. 3 times 5 is 15, so that's going to be a 15n. And there we have it. That's our solution in number 9. 3n cubed minus 18n squared plus 15n. Let's move on to number 10. In number 10, again, we have 3 terms within our polynomial. So when we take our monomial, we're going to distribute it in 3 different times, to the 2k squared, to the 5k, and to the 4. So when I write this out, I'm going to have 2k cubed, that's our monomial, times the first term, 2k squared, plus 2k cubed, times that second term of 5k, and again, this was addition in between, and then we're going to subtract, so minus 2k cubed times 4. Again, those signs, you're just keeping them in the same order, plus and minus. So doing out this math, I have 2 times k cubed times 2 times k squared. 2 times 2 is 4, and think about k cubed times k squared. K cubed is 3 k's multiplied together, so k times k times k, and k squared is 2 of those k's multiplied together, k times k. So if I have 3 k's times 2 k's, there's my k cubed, there's my k squared, that's going to be equal to k to the 1, 2, 3, 4, 5, k to the 5th. And again, 3 plus 2 is equal to 5. So we could have used that law of exponents there as well. So we have 4 times k to the 5th plus 2 times k cubed times 5 times k. 2 times 5 is 10. K cubed times k, that's 3 k's, k times k times k, multiplied together. And we're going to multiply it by a single k. That's 1, 2, 3, 4 k's multiplied together. So that's going to be k to the 4th. Or k to the 3 plus 1. Again, k to the 4th. So writing that out, we have 10k to the 4th. And then finally, we're subtracting 2k cubed times 4. 2 times 4 is 8. And that's multiplied by that k cubed. So 4k to the 5th plus 10k to the 4th minus 8k cubed is our solution in number 10. Let's move on to number 11. In number 11, using those same methods, we're going to distribute our monomial, 8r squared, into each of the terms within our polynomial. So starting with 8r squared times 4r squared, then we're going to subtract 8r squared times 5r. And then we're going to add 8r squared times 7. Working this out, 8 times 4 is 32. R squared times r squared, r to the 2 plus 2 is r to the 4th. So 32r to the 4th minus 8r squared times 5r. 8 times 5 is 40. And we have r squared times r, which is r cubed, because we have r times r as r squared times another r. That's 3 r's that we were multiplying together. So that's r cubed, r to the 3rd. And then we're going to add that to 8r squared times 7. 8 times 7, 56 times r squared. So for number 11, we have 32r to the 4th minus 40r to the 3rd plus 56r squared. Moving right along to number 12, we have a 3 out in front, and that's going to get distributed to 3v squared, 8v, and finally 5. So starting with 3 times 3v squared, then we're going to add 3 times 8v, and then we're going to subtract 3 times 5. So 3 times 3 times v squared, 3 times 3, doing that first, is 9, so we get 9v squared, plus 3 times 8 times v, well, 3 times 8 is 24, so that's going to give us 24 times v, or 24v, and then 3 times 5 is just 15, so we're going to be subtracting 15. So 9v squared plus 24v minus 15 is our solution in number 12. Moving along to number 13, again, our monomial out in front is just a simple constant, and we're going to be distributing that through to each of our terms, each of those 3 terms within our polynomial, and for this problem, we have addition in between all of those terms. So we're going to take 7 and multiply it by 6x squared. Then we're going to add that to 7 times 9xy, and then we're going to add that to 7 times 10y squared. Doing out this math, 7 times 6 times x squared, the 7 and 6 can be combined to get us 42, so that's going to be 42x squared. We're going to add that to 7 times 9 times x times y. 7 times 9 can get combined together to give us 63, but x and y cannot be combined any further, so they're going to remain as x times y, and then we're going to be adding that to 7 times 10y squared. 7 times 10 is 70, and we're going to leave the y squared as is. So we have 42x squared plus 63xy plus 70y squared. That's our solution for number 13. Moving on to number 14, we have 2u times 6u squared minus 9uv plus v squared. So taking that monomial and multiplying it to our polynomial, we're going to start by taking 2u and multiplying it by the first term in our polynomial, 6u squared. Then there's subtraction next, so we're going to subtract our monomial of 2u multiplied by the next term in our polynomial, 9uv. And then finally, there's addition, and we're going to add our monomial of 2u multiplied by v squared, that last term in our polynomial. So 2u times 6u squared, 2 times 6 is 12, and u times u squared is u to the third, or u cubed. And then we subtract 2 times 9 is 18, but that's also multiplied by u, and v. So multiplying our two u's together, since they're the same variable, u times u is u squared, and then we still have that v. So 18u squared v is multiplying out 2u times 9uv. Then we'll add that to 2u times v squared. None of those terms can be combined together, so it just stays as 2uv squared. So that's our solution for number 14. 12u cubed minus 18u squared v plus 2uv squared. Let's move on to number 15. Number 15 is our second to last problem on this worksheet. So if you stuck with me so far and have been finding this video helpful, please feel free to give me a thumbs up. Go ahead and click that like button or leave a comment below letting me know. But anyway, let's finish this out. We're going to take our 9 and multiply it by our first term, add it to the multiplication of it with our second term, and then subtract it with our multiplication by our third term. So again, we're going to take 9 and multiply it by x squared. That's going to give us a 9x squared. And then we're going to add that to 9 times xy, which 9x and y are all different things that can't be combined. So that's going to remain as a 9xy. And then finally, we're going to subtract multiplying 9 by 8y squared. We can do the 9 times 8, that's going to give us 72, but the y squared will still just be as is. So we're going to get 9x squared plus 9xy minus 72y squared as our solution for number 15. And this was just doing the math out in my head as I was distributing through, since for this problem, lots of those terms, once multiplied, couldn't be simplified down. So it was fairly simple to do in our heads. But let's continue on to that last problem. The last problem on this worksheet is number 16. It's a monomial of 9v squared multiplied to a polynomial u squared plus uv minus 5v squared. So we're going to start by distributing that monomial through. So we're going to have 9v squared times u squared, and then we're going to add 9v squared times u times v, because that u times v is that next term, and then we're going to subtract 9v squared times 5v squared. So doing out these last multiplications on the worksheet, we have 9v squared times u squared. Nothing can be combined there. So that's going to remain as a 9v squared u squared. And then we're going to add 9v squared times u times v. V squared can be combined with v to give us v cubed, because we're multiplying v times v times v. So we're going to have 9 times v cubed times u. So 9v cubed u, and then we're going to subtract 9v squared times 5v squared. 9 times 5 is 45. V squared times v squared is v to the 4th. And there we have it, the last solution on this worksheet. 9v squared u squared plus 9v cubed u minus 45v to the 4th. If you have any questions, please feel free to leave them in the comments below. I'll also leave a link in the description below so you know how to access this free KutaSoftware worksheet. But as always, don't forget to like, subscribe, and share. Happy learning!